So we had just started talking about law of sines as a method and way to solve non-right triangle or right angle triangles. Another way is law of cosines. Law of cosines is a little bit more intensive. The great thing with law of cosines is you use it once for a problem, and after you've used it once, you could then use the law of sines to solve every other part of the triangle, which is nice. You are going to be combining the two. Law of cosines is a little bit more restrictive too. You can only use it in certain instances. So just like the other day, we've got a triangle here. A, B, and C are our angles, and their corresponding sides go with that same letter. So we have the formula here, and there's actually 3 different versions of the formula, but I'm going to write down the first one. So if we wanted to solve for this side over here, side A, we would say A, that side, squared, equals, then our other 2 sides, which are B squared, plus our other side, which is C squared, minus 2 times our 2 sides that we know, B and C, times the cosine of the angle that goes with the side we're looking for. Since we're looking for angle or the side A, that means the angle it goes with is angle A. And that is the law of cosine. So like I said, a little bit lengthier. So like I said too, you can only use it in certain instances. You can only use it if you see side angle side to start off your problem, or side side side. If you see any other combination, you're going to use law of sines first instead. So it's a little bit quicker. So let's look at our first example here. Our goal is to find the side B as well as angle A. So like I said, most times when we're doing these problems, you're going to use the law of cosines once and then follow that with using the law of sines to find all the other missing parts you may need. So we're going to find the side first. We're going to find side B. So what we're going to write is we're going to say B squared equals. Now our other 2 sides they give us are this 28 and this 32. So I would say 28 squared plus 32 squared minus 2 times my first side, which we said was 28, times my second side, which is 32, times the cosine of angle something. Now again, we're solving for side B, so the angle that goes with that is that 43 degrees. So when looking at this problem, this angle that the variable we're solving for is over here by itself, which is great, because that means I could type this whole thing right into my calculator and find a value. So what we're going to do is we're going to pull out your calculators. I'm going to do it with you here. So it is 28 squared plus 32 squared minus 2 times 28 times 32 times the cosine, 32 times the cosine of 43 degrees. And we're going to push enter. So we have 497.414. So I'm going to go and write that into our equation there. B squared equals 497.414. And we're not done yet because it's still B squared. So how do we go from B squared to B? Well, we just take the square root of both sides. So it's the square root of 497.414. If I type that into my calculator, I'm going to get that B is 22.3. So B is 22.3. Up next, we need to find angle A here. All right, so when we find angle A, we're going to use the law of sines. So we're going to find the combinations. Well, the side and angle we know go with B. So we know that the sine of 43 degrees divided by 22.3 equals the sine of angle A, which is what we're trying to find. The side that goes with A is 28. And now we solve like we did yesterday. We're going to cross multiply. So 28 times the sine of 43 equals 22.3 times the sine of A. Our goal is to get that variable by itself, so the first thing we do is get rid of that 22.3, so I'm going to divide by it. And I'm going to type that into my calculator, so 28 times the sine of 43 divided by 22.3, and we're going to do 4 times places, so 0.8563 equals the sine of A. When we don't know the angle, if you recall, we have to do the inverse. We're going to do sine inverse of 0.8563. And when we do that, we get A is 58.9 degrees. So like I said, we use the law of cosines once and then follow it with the law of sines to find anything else. Once we have A, we could quickly find C by just doing 180 minus the two angles they've given us. So that's one example. That's when we're starting off with side, angle, side here. We had side, angle, and side here. The other way we use this is when we see side, side, side. So in this problem, we're going to find all of the missing angles. Now, when we do a problem which starts with side, 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 you need to find the largest angle first. How we figure out which one's the largest angle is whichever one's is opposite or across from the largest side. So if you look at my side lengths, I've got 7, 14, and 15. So my largest angle is going to be across from my largest side. So 15. So my largest angle is going to be E. So we're going to find E first. Now, since we have all three sides here, all right, we're going to kind of start with our largest side. So our largest side is 15. So you're going to say 15 squared equals my other side, which is 7, plus my other side, which is 14. Minus 2 times my first side of 7 times 14 times the cosine of the angle that goes with 15. Well, the angle that goes with 15 is this E. That's the thing we don't know. So here's what makes this problem challenging. We have to get this E by itself, all right? And it's currently not like it was last problem. So we have a lot of work to kind of get there. So what we're going to do first is we're going to get rid of these first and then get rid of those. So I do this all on my calculator. So let's get our calculator. So it's going to be 15 squared, and then you're going to slowly get rid of everything. So the next thing on that side was 7 squared. So you're going to say minus 7 squared. The next thing was minus 14 squared. So I moved both of those first items over with subtraction, and I get that number. Now I need to get rid of the negative 2, the 7, and the 14. I get rid of each of those by doing division. So divided by negative 2, enter. Divided by 7, enter. And then divided by 14, enter. And I get 0.1020. So right now what that looks like is I've got 0.1020 equals. So I've gotten rid of this, 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 and this. So all that's left is the cosine of E. When I don't know my angle, we have to do the inverse. You're going to do cosine inverse of 0.1020. So when I do the cosine inverse, I get that E is 84.1 degrees. Once we use the law of cosine once, we don't have to use it again. We can just use the law of sines for everything else. So I'm going to say the sine of 84.1 divided by 15 equals. Now, it doesn't matter which one you solve for next. So let's go ahead and solve for angle D. So I'm going to say the sine of D over 7. We're going to go ahead and cross multiply. So I get 7 times the sine of 84.1 equals 15 times the sine of D. To get that D by itself, we have to get rid of that 15 and the sine. So first we're going to divide by 15. When I type in 7 times the sine of 84.1 divided by 15 into my calculator, I get 0.4641 equals the sine of A, or sine of D. And in order to find the angle, we have to do the sine inverse of 0.4641. And that gets me 27.6. Then to find the last angle, all you have to do is 180 minus 27.6 minus 84.1. And you get 68.3. And now we found all of our missing angles.